So we're going to start by looking at a limiting reactant question. I picked a chemical equation that would have a lot of different coefficients in it and might help us really see how to do these. So the following reaction is studied. It's nitric acid plus copper giving copper nitrate, copper 2 nitrate, water, and nitrogen dioxide. So if 0.5 grams of copper are reacted with 1.2 grams of nitric acid or HNO3, what is the limiting reactant? So besides the fact that it asks what the limiting reactant is, we know we have to do a limiting reactant problem if amounts of both reactants are listed and it doesn't tell you which is in excess or what is extra. So when I'm trying to determine limiting reactant, I usually read ahead. So the next question says how much NO2 will be produced in grams. So that's this. So what I'm going to do is I'm going to figure out how much NO2 is produced using both 0.5 grams of copper and then 1.2 grams of nitric acid. And I kind of do them at the same time. So 0.50 grams of copper, 1.2 grams of HNO3, 1 mole of copper is 63.5 grams of copper. 1 mole of HNO3 1 mole of HNO3 is a hydrogen, a nitrogen, and 3 oxygen, so 63 grams per mole. So we never work in grams, we always go to moles. So remember, we have our steps. The first step is balance the equation. Our second step will be convert to moles. We now need to apply the stoichiometric ratio. So on top we write what we want, so moles NO2, and the number of moles we have is whatever the coefficient is. I'm going to the same thing for both of these expressions, so they're both going to be what's on top. What goes on bottom is whatever is here, so I know it's going to be moles of copper. I go to my equation and get the coefficient, which is a 1. Moles HNO3 and we go up and we get 4. So we change it to the step 3 as we apply the ratio. Now I'm just going to go to moles just because I'm light on space. So we'll do the first one, 0.5 divided by 63.5 grams. So that's how many moles we have. And then times 2, divide by 1. I'm going to get 0.0157 moles of NO2. The second one I have 1.2 divided by 63 times 2 divided by 4, and I get 0.00952 moles of NO2. So when you get the number of moles of NO2, or the product that you've chosen, pick the one that's the smallest, which is this one, clearly. So whatever reactant caused that, the nitric acid in this case, that must be your limiting reactant. So the limiting reactant is HNO3. So that means that this, the copper, is your excess reactant. The limiting reactant will control how much product you make through this entire process. So as we continue to go through, we're always going to come back to that 1.2 grams. So how much nitrogen dioxide will be produced in grams? Well, we already figured out how many moles will be produced because we're just going to use the smaller of the two. That's always the case. And we just need to convert back to grams. So this is technically step 4. I didn't have a step 4 up there. Remember, there are 4 steps: balance the equation, convert to moles, apply the ratio, and then convert to the unit you're being asked. So the molar mass of nitrogen dioxide is 14 plus 32 is 46 grams. So 46 grams of NO2 is equal to 1 mole NO2, 0.00952, 0.438 grams NO2. I only have 2 significant digits, so 0.44 grams would be my, I can put NO2 with that, would be the mass of NO2 produced, again, now that I know my limiting reactant. What volume of NO2 would be produced? Well, once again, we can use that number that we picked earlier, and it's at STP, so that's 0 degrees Celsius and 1 atmosphere of pressure. Standard conditions otherwise. So the conversion from using the molar volume is 22.4 liters for every mole of gas. So 0.00952 multiplied by 22.4 equals 0.213 liters of NO2. Still have 2 significant digits. So 0.21 liters NO2. Again, really the difference we're doing here from a regular stoichiometry question, or at least one where we don't have to worry about limiting reactants, is just this first step. Once we've determined the limiting reactant, we know what we have to do. So the final question is how much excess reactant will remain at the end of the reaction? So our excess reactant is copper. So what we're going to do is we're going to take our limiting reactant and figure out how much copper was used if all of it was used. So anytime we're doing calculations now, we start with our limiting reactant. So we go back up and get the 1.2 grams HNO3, convert to moles. There obviously is a benefit to writing out what the moles are, so you don't have to do this step every time, but it doesn't really matter. So we're in moles. I want to go to moles of oxygen. So oxygen, moles of copper. And the number of moles of copper is 1 for every 4 moles of HNO3. So it's 1 to 4, where I get oxygen. And I'm going to convert to grams. So 63.5 grams of copper for every 1 mole of copper. So let's go through our calculation. 1.2 divided by 63. So I'm in moles, divide by 4. So now I'm in moles of copper times 63.5. 0.302 grams of copper must have been used. So again, that's what was used. The question is asking us how much is left. So I had 0.50 grams of copper to start. I take away what I used, and that will tell me how much I have left. So 0.5 take away 0.302. Still constrained by those significant digits. So my answer is 0.20 grams of copper. That's pretty much how all those